The magnetic quantum number ml proposed by Lande. The magnetic quantum number ml has integer values between -L and +L including 0. Thus, for a certain value of L, there are 2L plus 1 integer values of ml as follows: -L to +L including 0. These values describe the orientation of the orbitals in space relative to the other orbitals in the atom. When L is equals to 0, substitute this value in 2L plus 1, then we get 1. And there is only one value of ml, thus we have only one orbital, that is s orbital. S orbital is spherical shaped. When L is equals to 1, substitute L equals to 1 in 2L plus 1, we get 3. That means ml has 3 values, namely -1, 0 and +1, or 3 p orbitals with different orientations along x, y, z axis, and these are labeled as px, py and pz. P orbitals are dumbbell shaped. When L is equals to 2, 2L plus 1 is equals to 5. That means ml has 5 values, namely -2, -1, 0, 1 and 2, or 5 d orbitals with different orientations, and these are labeled as dyz, dxy, dxz, dxy, dx square minus y square and dz square. D orbitals are double dumbbell shaped. The number of ml values indicates the number of orbitals in a subshell with particular L value. Maximum number of electrons in orbital is equals to 2 into 2L plus 1. Let us define what are degenerated orbitals. Orbitals in the subshell belonging to the same shell possess same energy, and these orbitals are called degenerate orbitals. Px, Py, Pz are degenerate orbitals. Similarly, dyz, dxz, dxy, dx square minus y square, dz square are also degenerate orbitals. Let us fill the table. When n is equals to 1, then L is equals to 0, which is represented as S subshell, and the ml value for L equals to 0 is equals to 0, and subshell notation 1s, 1s. When L equals to 0, the number of orbitals in the subshell is 2L plus 1, then we get 1. So there is only one orbital in this subshell, that is s orbital. For L is equals to 0, the maximum number of electrons in orbital, we have the formula 2 into 2L plus 1, then we get 2 electrons. That means in s orbital there are only 2 electrons can exist. Now maximum number of electrons in a main shell, for example n equals to 1, let us find the maximum number of electrons in the main shell. We have the formula 2n square. Substitute this value in this equation, we get 2. That means 2 electrons are the maximum electrons in the first main shell. Similarly, we have to fill this table taking n equals to 2, n equals to 3, n equals to 4, and taking other values of L and ML, and we have to fill this table. Spin quantum number ms proposed by Uhlenbeck and Goudsmit, as you have observed in the case of street lights, sodium vapor lamp, yellow light is emitted. You can see in figure. This yellow light is comprised of a very closely spaced doublet. When analyzed using high resolution spectroscope. Alkali and alkaline earth metals show such type of lines. To account for such a behavior of electron, an additional quantum number is introduced. This is spin quantum number. This represents the property of the electron. It is denoted by ms. The quantum number refers to the two possible orientations of the spin of an electron, one clockwise and the other is anti-clockwise spin. These are represented by plus of and minus of. If both are positive value, then the spin are parallel, otherwise the spins are anti-parallel. The importance of the spin quantum number is seen when electrons occupy specific orbitals in multi-electron atoms. Spin is an intrinsic property of electron. See here hydrogen. So it has only one electron and it will occupy in 1s orbital. Similarly, helium has 2 electrons. So these 2 electrons will occupy in 1s orbital. You can see the spins of electron are anti-parallel. So you can see this diagram. In all these elements, electrons occupy in different orbitals with different spins. Mostly in each orbital, electrons are existed in anti-parallel way.